Okay, following down, we're going to go basically right through this, go through all the symbology on the Enroute chart, talk about different things, okay? All right, a VOR without DME. Right there. A VOR with DME. Right there. So a DME symbol, all by itself.
What is that called?
Full circle thing.
This right here is a DME symbol. That little serrated thing. So a serrated DME circle inside of a VOR is a VOR with DME. Okay? Does Jeppesen depict vortex? Okay. Vortac, TACAN. We don't have TACAN capability. Jeppesen only sells to civilian people. So they don't differentiate between a VOR, DME, and TACAN because TACAN to us means DME. So Jeppesen, on a federal chart, you have 3 different symbols. On our chart, you got a VOR with DME, you got a VOR without DME. End of story. Keep it simple. Okay? Okay, now if I look, I've got this VOR over here, notice has no box around the frequency, but this one does. Why does this one get a box and that one doesn't? Alright, what kind of chart is this? Enroute chart. This is not part of the Enroute structure. Therefore, it's not a primary nav aid. Jeppesen will always highlight the primary nav aids for whatever chart you're using. If you have an ILS chart for an approach chart, guess which frequency is going to have a big dark box around it? The localizer frequency. Okay? So that's how you know what a primary nav aid is. What does unmonitored mean if I see it next to a VOR or localizer? Unmonitored. It means that there is no equipment that's actually going to alert anyone if that breaks or malfunctions. Okay, so when it says unmonitored, it's just giving you a warning saying, hey, could be broken. If you see anything erratic, now you know why. All right. Got my little hand. Okay. What's this right here? 10,700. MEA. MEA guarantees me what 2 things?
Obstacle clearance and navigational.
Obstacle clearance and navigational coverage. Does it guarantee me radar?
No.
No, it does not. Okay. How much terrain or obstacle clearance? Okay, 2,000 over mountainous, 1,000 over non-mountainous. How is mountainous area defined?
Western U.S.
Okay, in the AIM, there's a nice little chart, a little map that shows that pretty much everything west of Denver is mountainous and over in the Appalachian mountain areas. Okay, why is that important? Well, if you were in a real emergency situation, knowing whether you had 1,000 feet or 2,000 feet before you hit the top of the mountain, it's good to know.
Doesn't Jeppesen describe it in the intro?
They give the international, the ICAO definition. So, unfortunately, I wish the U.S. used everything ICAO. I can't keep track of what's ICAO and what's not. But Jeppesen does list it in there. The reason, though, is because that legend is published for international charts also. So I'm not sure if it really applies to the U.S. Mountainous area is actually defined in FAR Part 75, I believe, which is not published in our little book we buy. So, I have no idea why, but that's where it's read. It's pretty much,
How is it defined?
it's the chart. There's a chart, there's the actual map in the AIM that shows you mountainous terrain, non-mountainous, and then there's that same map is actually included in the Jeppesen legend. So, that map, that's pretty much what it is. Make sure you know that map. Okay, I've got, this is horrible. I'm used to looking at this thing upside down. Okay, right here I've got 9200 T. What's a T? A MOCA. A MOCA gives me what?
22 miles an hour.
22 nautical miles of navigational coverage and obstacle clearance. So,
Question on the MOCA. So, 22 nautical miles from what?
from the VOR. So that means that I would technically have navigational coverage out here until Rays because it tells me I have 22 miles right there.
How do you know which VOR to use? as in, like with that example, do you use Fillmore or do you use the other one?
From here,
How do you know?
because it's only for this segment.
Oh,
Notice up here, there's no mocha.
gotcha.
So here's one thing to be careful about with mochas, is those mochas are only valid for the segment they're shown. So this mocha right here is only valid between Piru and Rays. After that, the mocha disappears. So it's one thing you got to kind of watch for.
What does the T stand for? I guess just be.
T, I always think of it as T for terrain, terrain only. That's pretty much what it is. I've got an MEA of 11,000. MEA brakes are depicted with these little T-bars. So little T-bars along the intersection. So this intersection has no T-bars. It's because it stays at 11,000. The only difference here is it's published twice because the mocha changes. So because I've got a mocha here and not over here, they republish 11 and 9.2. So MEA change is depicted by the crossbars, the T-bars at an intersection. Just like right here, I've got 4 T-bars. So I go from 9,000 or 8,000 to 9,000, 8,000, or going this direction, I go from 8 to 9 also. Okay, so right here coming outbound, I've got an MEA of 9,000 feet. It goes up to 11,000 feet right here at Piru. When is the latest that I can start my climb and still be safe? At Piru. Let's come down over here. And I've got an MEA of 10,700. Come along the airway and we find right here's the MEA change. And it changes to 13,500. When can I start my climb?
Aaron.
Awesome, we all died today.
I have to be at that altitude.
Because at Aaron,
MCA,
I have an MCA. So here's the one thing that I don't like about Jeppesen Enroute charts. The FAA charts put like a little flag on the intersection. It's really easy to see. Jeppesen just puts the MCA, and they really kind of blend in when you have a busy chart. Okay, MCAs are killers. You got to watch for them. So I got an MCA of 12,000 feet. So I've got to cross a RAN at 12,000. If I crossed a RAN at 10,700 feet, I would probably not make my climb gradient. Okay. Climb gradients. Does anybody have an instrument procedure handbook with them? Look at that. See that?
What's that?
What?
It will maintain 150 feet per mile between sea level and 5,000, 120 feet.
Oh, you've got it right there.
Yeah, between 5,000
Look at that.
and
You can just read it to us. I can never remember them. So, say that again.
150 feet per nautical mile between sea level and 5,000 feet AGL, 120 feet per nautical mile between 5 and 10, and 100 feet per nautical mile above 10,000.
Above 10. Okay. So the climb gradients required for en route climbing is not that much. 150 feet per nautical mile, that's like nothing. Between sea level and 5,000. 5 and 10 is 120 feet per nautical mile and then 100 feet per nautical mile above. When you really calculate that out, it's not very many feet per minute. So most airplanes can meet those climb gradients just fine. But, once again, when you're up that high in a diamond star, guess what? You're probably right at the climb gradient. So if you start, what is that, 1,300 feet low, there's a good chance you might have some problems.
Hey, what page is that?
It's 510.
All right, what is the main purpose of ATC? Traffic separation. That's it. That's their job. Are they supposed to separate you from terrain?
Nope.
Nope. Most of the time they get the terrain warning about, 10 seconds before you hit the terrain. Terrain alert, sorry! Anyway. So that's not their job. They do have, the computer is programmed to tell them when you get close to terrain, but that's not their job at all. So that's why you'll read reports of stuff where you think, why didn't the controller do something? Because it's not his job. His job is simply to provide separation services. And that's why they're so limited on capability sometimes. Okay, I don't have an example of this, but an MRA. I'm sorry. The MRA I do. It's the MAA.